The second law of thermodynamics. Any device which converts heat into mechanical energy is called heat engine. The essentials of a heat engine are the furnace or the hot body, the working substance, and the condenser or cold body. In a steam engine, the steam absorbs heat from the furnace, converts some of it into work by applying pressure to the piston, and rejects the rest of the heat to the condenser. The point to note is that the furnace is at a higher temperature than the condenser, and the conversion of heat into work is possible when the working substance falls in temperature. We can generalize it by saying that the two bodies must be maintained at different temperatures for the working of a heat engine. A continuous supply of work has never yet been obtained from a single supply of heat. Otherwise, we could build a ship which could use far more heat in ocean water without needing any fuel. This leads to the first way of stating the second law of thermodynamics due to Kelvin. According to Kelvin, it is impossible to create, it is impossible to derive, it is impossible to construct, it is impossible to derive a continuous supply of work by cooling a body to a temperature lower than that the coolest of its surrounding. What? I am repeating. It is impossible to derive a continuous supply of work by cooling a body to a temperature lower than that of the coldest of its surrounding. It is impossible to derive a continuous supply of work by cooling a body to a temperature lower than that of the coldest of its surrounding. Let us consider the fact that no one has ever built a refrigerator which will work without the supply of energy. A refrigerator is essentially a machine for conveying heat from one body at a lower temperature to another at a higher temperature, as shown in figure 11.3. If you have the physics book of Sense Book Board Jam Shoro, open up page number 31 and you can see in the figure and you can understand what they are doing there. Okay, in other words, it is only possible to make heat flow from a cold body to a hot body by using upwork. The statement of second law of thermodynamics due to Clausius comes from the consideration of the fact of refrigerator, and it is stated: it is impossible to cause heat to flow from a cold body to a hot body without the expenditure of heat. We shall now prove that both these statements are equivalent by showing that if either of these statements are supposed to be false, the other must be false also. We suppose that Kelvin's statement is false. Then we could have a heat engine which takes heat from a source and converts it completely into work. If we connect this perfect heat engine to an ordinary refrigerator, we can take heat from hot body and convert it completely to work. This work can be used to operate the refrigerator, which conveys heat from a cold body to hot body. The net result is a transfer of heat from a cold body to a hot body without the expenditure of work, which is contrary to Clausius' statement. According to Kelvin's statement, an engine, when converting heat into mechanical work, cannot convert all of it into work. A part of the heat must be rejected to a cooler reservoir, the exhaust. In other words, it is impossible to devise a machine that would have an efficiency of 100%, even though the first law of thermodynamics will be satisfied.